So here's the problem. Once again, we've got our 2 by 2 system, or n by n if you want to be super general. There's our system. What have we got so far by way of solving it? Well, if somebody, your kid, brother or sister, when you go home says, okay, precocious kid says, okay, so tell me how to solve this thing. I think the only thing you'll be able to say, well, you do this, you take the matrix, and then you calculate something called eigenvalues and eigenvectors. You know what those are? Yeah, I didn't think you did, blah, 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 well, how smart I am. And you then explain what the eigenvalues and eigenvectors are, and then you show how to, of those, make up special solutions, and then you take a combination of that. And in other words, it's an algorithm. It's something you do, a process, a method. And when it's all done, you have the general solution. Now, that's fine for calculating particular problems, with definite numbers, a definite model with definite numbers in it where you want a definite answer. And of course, a lot of your work in engineering and science classes is that kind of work. But the further you get on, well, when you start reading books, for example, or God forbid, start reading papers in which, people are telling you, they're doing engineering or they're doing science. They don't want a method. What they want is a formula. In other words, the problem is to fill in the blank in the following. You're writing a paper, and you just set up some elaborate model, and A is a matrix derived from that model in some way, represents bacteria doing something or bank accounts doing something, I don't know. And you say, as is well known, the solution is, of course, you've only got letters here, no numbers. This is a general paper. The solution is given by the formula the only trouble is we don't have a formula. All we have is a method. Now, people don't like that. So what I'm going to produce for you this period is a formula. And that formula does not require the calculation of any eigenvalues, eigenvectors, doesn't require any of that. It's therefore a very popular way to finish that sentence. Now the question is, where's that formula going to come from? Well, we are, for the moment, clueless. If you're clueless, the place to look always is, do I know anything about this sort of thing? I mean, is there some special case I could solve of this problem I could solve, or that I have solved in the past? And the answer to that is yes. You haven't solved it for a 2 by 2 matrix, but you have solved it for a 1 by 1 matrix. A 1 by 1 matrix also goes by the name of a constant. It's just a thing. It's a number. You're just putting brackets around it doesn't conceal the fact that it's just a number. So let's look at what's the solution for a 1 by 1 matrix. The 1 by 1 case. If we're looking for a general solution for the n by n case, it must work for the 1 by 1 case also. That's a good motivation, a good reason for us starting. That looks like x, doesn't it? X inside 1 by 1 case. Well, in that case, I'm trying to solve the system. The system consists of a single equation. That's the way the system looks. How do you solve that? Well, you were born knowing how to solve that, or you, anyway, certainly didn't learn it in this course. Solution is, well, you separate variables, blah, 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 blah. And the solution is x equals, the basic solution is e to the at, and you multiply that by an arbitrary constant. Now, if that's a formula, it's a formula for the solution. And it uses the parameter in the equation. I didn't have to know a special number. I didn't have to put a particular number here to use that. Well, The answer is that the same idea, whatever the answer I give here, it's got to work in this case too. So I'll just, let's take a quick look as to why this works. Of course, you separate variables and use calculus. I'm going to give you a slightly different argument, which has the advantage of generalizing to the n by n case. And the argument goes as follows for that. It uses the definition of the exponential function not as the inverse to the logarithm, which is where the fancy calculus books get it from, nor as the naive high school method, it's e squared means you multiply e by itself, and e cubed means you do it 3 times, and so on, and e to the 1/2 means you do it a half a time or something. So the naive definition of the exponential function. Instead, I'll use the definition of the exponential function that comes from an infinite series. So leaving out the arbitrary constant, which we don't have to bother with, e to the at is the series 1 plus at plus a squared t squared over 2 factorial. I'll put out one more term, and let's call it quits there. If I take this, and then the argument goes, let's just differentiate it. In other words, what's the derivative of e to the at? With respect to t? Well, just differentiating term by term, it's 0 plus the first term is a, the next term is a squared times t. This differentiates to t squared over 2 factorial. And the answer is that this is equal to a times, if you factor out the a, what's left is 1 plus at plus a squared t squared over 2 factorial. In other words, it's simply a e to the at. In other words, by differentiating the series, using the series definition of the exponential, and by differentiating it term by term, I can immediately see that it satisfies this differential equation. What about the arbitrary constant? Well, if you like, you can include it here, but it's easier to observe that by linearity, if e to the at solves the equation, so does the constant times it, because it's linear. The equation is linear. Now, that's the idea that I'm going to use to solve the system in general. What are we going to say? Well, what could we say? The solution to, well, it's better, let's get 2 solutions at once by writing a fundamental matrix. So a fundamental matrix, I don't claim it's the one, a fundamental matrix for the system x prime equals ax. So that's what we're trying to solve. And we're going to get 2 solutions by getting a fundamental matrix for it. Then the answer is e to the at. Isn't that what it should be? That little guy had a little a. Now we've got a matrix. Okay, just put the matrix up there. Now, what on earth is... The first person who must have thought of this, it happened about 100 years ago. What meaning should be given to e to a matrix power? Well, clearly, the 2 naive definitions won't work. The only possible meaning you could try for is using the infinite series, but that does work. So this is a definition I'm giving of the exponential matrix. It is. Now notice, the A is a 2 by 2 matrix, multiplying it by t. What I have up here is basically a 2 by 2 matrix. Its entries involve t, but it's a 2 by 2 matrix. Okay, it's going to be, leave out, so we're trying to get the analog of that formula over there. Well, it's going to be, leave the first term out just for the moment. The next term is going to surely be a times t. This is a 2 by 2 matrix, right? What should the next term be? Well, a squared times t squared over 2 factorial. What kind of a guy is that? Well, if A is a 2 by 2 matrix, so is A squared. How about this? This is just a scalar which multiplies every entry of A squared, and therefore this is still a 2 by 2 matrix. That's a 2 by 2 matrix. This is a 2 by 2 matrix. No matter how many times you multiply A by itself, it stays a 2 by 2 matrix. It gets more and more complicated looking, but it's always a 2 by 2 matrix. And now I'm multiplying every entry of that by t cubed, the scalar t cubed over 3 factorial, and continuing on in that way. What I get, therefore, is a sum of 2 by 2 matrices. Well, you can add 2 by 2 matrices to each other. We've never made an infinite series of them, but in fact, we haven't done it, but others have. And this is what they wrote. The only question is, what should we put at the beginning? Over there, I have 1, the number 1, but I, of course, cannot add the number 1 to 2 by 2 matrices. What goes here must be a 2 by 2 matrix, which is the closest thing to 1 I can think of. What should it be? The I. 2 by 2 I. The 2 by 2 identity matrix looks like the natural candidate for what to put there, and in fact, it's the right thing to put there.